Thank you, Dana. Thank you so much. And thank you so much for coming. It's a real pleasure to be here. The drive from Ithaca was perfect. It's like, see another Ithaca 4 hours later. So I should mention that this is a, so everybody knows, this is a reunion of sorts. Patricia was on my PhD committee at Johns Hopkins. So without her, I won't be here. And then Dana is my student from at Cornell, and so this three generation of migration scholars in the same room, which I thought it's a real treat. So thank you for this welcome. All right, so this is joint work with Felice. So in this paper, we're interested in thinking about the individual determinant of migrant border crossing locations and the role of networks. And so in short, conditional on migration, we are interested in how the forces that drive migrations to begin with, the push and pull forces of migration, determine how and where a migrant decides to migrate, to cross the border. And so already many questions. So what are these push and pull forces, and why are we interested in studying how people cross the border? And so just for context, then, so what we are hoping to be able to address, of course, is the humanitarian crisis that is currently at the border. And so we have here some information for you about how serious the problem is. And so this is just some information, of course, an undercount of the number of people who perish trying to get to where they want to go to. And so about 75,000 since 1998 are the estimated number of migrant deaths worldwide, of which about 10,000 happen between the US and Mexico. But of course, the reason why US and Mexico is an interesting case study, right, is that unlike perhaps crossing through the Mediterranean Sea, where crossing itself is a dangerous endeavor, the US-Mexican border, it's quite diverse in terms of its physiography. There are many places you can cross, some not as dangerous as others. And so why the upswing in migrant deaths in years is essentially the question that we're asking. And so just to give you a couple of perspectives, right? So there are a number of ways you can look at the problem. So one is what I call the border enforcement perspective. Right? So here you say the problem is there because of how countries decided to enforce the border. And so here I have a picture that I took from Associated Press reporting on the 31 migrants perishing in the British Channel in November 2021, and two Prime Minister and the President at the time basically illustrating the border perspective. The first saying that this is not going to happen, this won't happen if a border enforcement has been more intense. So I'll just read. It highlighted how efforts by federal authorities to patrol the beaches have not been enough, right? So to solve this migration crisis at the border, we need more enforcement. Second, no, it's not just more enforcement, but how you enforce it is also the issue. And so it's this debate between Chau and Boris Johnson basically about whether or not criminal gangs are involved. Right, so what we try to do in this paper is perhaps to refreshing the perspective to think about it in a migrant-centric way, right? And what we mean by that is that we want to understand this upswing in migrant deaths in recent years by looking at individual characteristics that drives perhaps individuals to engage in risky migration behavior. And in so doing, in thinking about the self-selection, we are hoping that we can chart a path towards more migrant-centric border enforcement policy. In particular, if we are thinking about applying priority weights to perhaps immigration quotas, who should get first pass, right? If we know that these are the people who are most likely to get risk. And so that's basically the perspective that we're trying to push forward here. The object that we study is basically this border. I think in this audience, I don't really need to say very much. The one thing that I want to mention is that there are 9 border sectors. These are essentially administrative sectors in the US, going from San Diego all the way to Rio Grande, where you get data on how many people are being hired to enforce the border in each sector, the amount of funding going into each sector, and so on. So we have good data on that. So it's a very natural way to divide the border, but of course not all points along the border is the same. And so just to give you an idea, here's a heat map of the same US-Mexican border. And so you can see everything from beaches to rivers to deserts. And not sadly, perhaps, but at the same time, people recognize that this is the situation. What we can also see is that border deaths is in line with climate. So what we have here is migrant remains found by Border Patrol in these years. And so on the horizontal axis of these diagrams, and blue diagrams here are years going from 1998 all the way to 2019. And so the upswing in migrant deaths is, I think, quite right? Any questions? Okay, so far. All right, so once again, so in order to get into this question, I'd like to give you some macro circumstances that surrounds what's going on, including the waves of undocumented migrants. I think most people here know upswing in migrant journeys through the hazardous crossing, sharply rising cost of migration. That Professor Massey in his work has taught us a lot, drastic increases in migrant deaths and how they die. And then finally, right, a cutoff that I think is really important for our study, which is in 1994, when it's called the Prevention through Deterrence Border Enforcement Policy. All right, so to get started, so here is a diagram that I think many of you might have seen already. This is the total number of apprehensions of undocumented migrants at the border, going all the way from 1960 to 2020. And so at the height of this movement of individuals, you will see about 1.6 million people per year, right, are apprehended at the border. And so that's quite a number. But our study period, and that's why these red lines are here, goes from 1980 to 2005. And so we're trying to capture a period of time where a lot of the undocumented migration is taking place. 2 more years that are important to note in 1986. So I'm a trade economist as well as the migration economist. And to me, migration policy and trade policy always happen together. And so in 1986, 2 things happened. Thank you. 1, that's a migration side. Tell me the trade side. Oh, come on. Yeah. Yeah, so Mexico joined the gap. 1994. It's easy to remember, it's not the same. Something about migration that happens, whether prevention. And so those are the main thing, which allow us to think a little bit about our identification strategy going forward as well. And so remember those critical time periods now. And so here we have using data from Mexican Migration Project, of course, where we have information on where migrants cross the border. And so here you will see starting from blue, right? So from blue, the lowest part of this diagram all the way to the top, it's basically the left to right of that same graph that you saw. Right? So this is San Diego all the way to Rio Grande. There, what you will see, of course, is this is where our study begins, this is where our study ends, but what you will see is that there's a huge shift in the fraction of migrants who decided to cross dangerously. Right? So the question is what is driving that? And so that's that. So a few other pieces of information that happen to be useful as well. We see, so this is also from using data from the Mexican Migration Project. This is a thin scatter of crossing costs by year. And so what we find is that there is a sharp increase in the cost of migration through smuggling, mostly during this period. What else? Of course, increases in migrant death. I made sure to take a picture from that famous paper. And so here it is. And so there's a sharp swing in migrant death at the same time. But finally, one more piece of information that I took from an earlier paper is how these migrants perish. And so hypothermia, dehydration, etc. Right? So all of these are evidence basically driving towards people are migrating, right? But they are taking dangerous journeys. And so the cutoff that I'd like to mention that will become a part of our identification strategy is what is called the prevention through deterrence policy. And so for those of you who are Googling away already, you Google prevention through deterrence and U.S. Border Patrol strategic plan, you will see that document. It's still online and it has these words in it. And so I will just phrase this for you. And so essentially it is an attempt to deter undocumented migration by disrupting, I mean, it's like cat and mouse, by disrupting traditional crossing paths. Right? I know where they've been coming, I will just catch them there. Right? And so, of course, what ends up happening is it's displacement of individuals that a lot of studies have been focusing on. And so here I list for you these very famous border operations, like hold the line, gatekeeper, safeguard, and so on in different parts of the border where many migrants cross. I also cite for you here the drastic increase in border patrol funding from the 1990s to now, right? So from about $500 million to $1.5 billion to now, just this last year, this summer announced $17.5 billion to be spent at the border in 2023 with 65,000. So all to do what? Right, to enforce the border. And so here's a line that I take from the strategic plan. With traditional entry and smuggling routes disrupted, illegal traffic will be deterred or forced over hostile terrains. Right? So this is basically expected to happen. And so why are we using that? In just a second. But what I'd like to therefore mention to you is that in much of the economic literature about border enforcement, right, we have used many border enforcement controls related to what we just saw, including some very famous paper on using border patrol person hours, border person hours plus, right, as an instrument, average prison terms of smuggling, because this endogeneity issue of border patrol, where you patrol the border, of course, is where people are coming, and border fencing as well. And so those are in terms of right-hand side variables. What are the controls? What are the outcome variables? Are these three papers that are just increasingly becoming well-read? The first paper, I think, in this literature is a Journal of Labor Economics paper by Gapman, which basically estimates the probability that a repeat migrant will switch, right? So her left-hand side variable is switching. Fagenberg, in a very recent paper, and Allen's paper, these are just, both papers are called border walls, right? They're both about the Secure Fence Act and how they might have an impact on the border. And so essentially they show the changes in crossing location intentions, right? And this is a more fancy paper using a general equilibrium model with trade and migration. Right, so our paper, it's not about any of this. Our paper addresses the literature that currently looks like this. We're trying to add some fun. So we wanted to ask how the pull and push factors of migration that we knew in this literature as factors that encourage migration from the destination, so I'm pulling you, or from the origin, I'm pushing you up, how these forces actually end up changing people's border crossing behavior. And so in this paper that I circulated a little earlier, and thanks, I want to thank Mary Lou for taking care of me. We wrote a very simple theory that talked about specify different sector-specific, border sector-specific rewards and risks, accounting for the costs of crossing and the push-pull factor of migration. But essentially, these two next lines are the prediction, which is very, to be expected. Strong pull forces, a migrant experience strong pull forces will tend to seek out loosely enforced, locations, because, to be able to cross is very important. Strong push forces, however, have an additional effect of compelling migrants to discount the risk of migration, discount the risk of hazardous crossing, because they're not giving up much. Right? So they're staying in the home origin, but has not much to offer because I'm being pushed. So the question, therefore, to test these hypotheses, one needs to think about the list of push and pull forces that might be useful. But as I explained earlier, it's not that easy, right? Because pull forces are oftentimes macro level, right? They're trade shocks, which conflate with, right, enforcement shocks, right? So these things happen. So it's a trade or it's an enforcement. Push forces are well known to conflate with cost of migration, right? If you're poor, right, oftentimes what happens is that the cost of migration that you need to pay is high. So again, this is non-linearity that is difficult to work. And so what we decided to do is to leverage the social context of migration, right? Where network connection with the destination, according to many people who are here, right, as well as others, we have shown that it is a strong pull factor of migration because it helps people to find jobs, social support, offer credit when you're abroad, which is very difficult for migrants. But at the same time, so after this, working on this paper, I read every single thing that police did. I learned a lot about the network that I didn't know before. And so this is one of them. So network connection with destination is a strong push factor as well, because oftentimes if the people who are around you, right, are migrating, there's a stigma associated with not doing what they're doing. Right, so there's a push factor as well that we need to take into account. So networks are great, right? It's both a push and a pull factor at the individual level. Right? Of course, there are confounders that we need to be careful with, and so individuals with family ties in the US, right? So this is our measure of network, may simply be located closer to a particular border sector of law enforcement, right? And so just because you're networked, right, doesn't mean that network is the thing that is making you cross via a particular network. And so we need to better identify that strategy, and this is it. So the prevention through deterrence program, right? We want to think of it as almost reversing the ranking of enforcement intensity between historically safe and historically hazardous crossing. And so what we are interested in is for those who have family network connections, do they change their behavior before and after this particular enforcement policy? And so that's basically the story of this paper. And so we will run some regression that I will show you, but essentially what is important is the middle part of this slide, where pre-1995, what we find is that people with network connections to the US are negatively selected in Tucson, right? So because actually San Diego is easy to cross, so we go to San Diego. So these are the more likely to cross through loosely enforced. Right, post 1995, though, we see a drastic change in their behavior, right, in the sense that they are now positively selected in Tucson, which makes us think that this is consistent with a story that network as a push and pull force is driving people's border crossing. So that's basically the story. If I finish this slide, I'm done. So we of course consider a number of alternative networking flows, which I will talk about, which end up being, I think, another interesting part of this paper. And then the implication, of course, of this paper is that there is something about family-based migration policy that we should think about a little bit more carefully, because if these are the ones that are more at risk at crossing and reunification, you have said perhaps that there really is a reason why we should be thinking about it. All right, so having said that, the contributions are as follows. So I will skip the first two because they are essentially what I talked about. And the third one that I don't want you to leave without thinking a little bit about is that even just network alone has multiple ways in which it affects how people migrate. And so we will try to address some of those as well. The network externality effects, we find that there are some network origins of smuggler price formation. Right, so we'll see that in just a second. Other than, in addition to the usual routes such as social. That's okay. All right, so here's the model. It would just be one page. All right, so it just helps us think about the problem. So there are capital K number of sectors. For us is 9. Each sector has a likelihood of being able to cross, right? So crossing success likelihood is PFK. That can change over time. Having an accident en route is PAK. So the complement to these things, being able to cross, not being able to cross is to return home. And so that's that. Associated with each of these events is a consequence, right? So VIB, VIA, VIO, where I is an individual, So when you are successful in migrating, you get the destination wage, let's say, or the totality of the utility of going abroad, plus something that has to do with network, right? So if kappa D is positive, having a network connection, and I is positive, gives you a pool. Right? So that's the pool. The push is here, right? So if having a network connection in the US makes it harder for you to stay put, that's the push, right? So that's minus kappa. So other than that model, really, so cost of crossing is very simple. There are some individual level determinants of cost, right? Either because your gender, your age, or where you're located. There's some costs associated with crossing to a particular sector, K, and then also depending on something that is joint, the distance between you and that sector. And so all this looks fine. Essentially, what we're trying to predict is the log odds of crossing via sector K relative to a base, which we will use San Diego as a base. And all you need to look at in this slide are that there are three sets of such factors. And the first is being highlighted for you here. So what we find is that there are alternative, right? Alternative here is border sector, individual across individual groups, such as your distance to the border. Right? So that differs across individuals and across borders. Right? And so for these factors, we will estimate Chau, which is the cost of cross of Chau. Secondly, we have these network effects, which are also interesting. The log odds of crossing via K relative to 1, depending on something that is specific to an individual and invariant, right? Regardless of border. So this is saying you have a family connection in the US. Does it make it more likely for you to cross via Tucson or less likely? So that's basically what it is. What we find is that it depends on these differences, right? So PSK minus U PS1 essentially is how much easier it is for you to successfully cross the border via sector K relative to that. Right? If it's positive, having a network will make it more likely for you to cross there. If not, right, if that difference is negative, you don't. Right? So what we're saying is that this is a logistic regression that provides alternative specific coefficients. So very important. Each sector has a coefficient. Right? And so K minus 1 number of coefficients. That's the case like that. For each one of these individual specific variables, that is what we're looking at. Right? And then if we interact these with year interval dummies before 95, after 95, we would expect the coefficient to flip these differences because of that. Okay, so that's our identification strategy. Finally, we have sector-specific context, right, to control for changes in border enforcement policy, changes in climate. And for those of you who might be wondering why we worked on this paper, so our first meeting was that. We were wondering how climate might have affected people's problem. Tough nut to crack. Not cracking it, fixed effects. All right, so that's fine. So data, so we use data from Mexican migration project. I don't need to talk too much about the details of this data set here, but I think the subset of that data that we use is of interest. And so we're looking at data where individuals cross for the first time, right? So no history to worry about between 1980 to 2005 to avoid single cells for year sector combinations. We look at adults making decisions for themselves. That leaves us with about 2,500 individual migrants times 9 because they have 9 binary yes or no decisions to make. Okay, so this is nonetheless a sizable data set to look at. Is 153 Mexican communities because we are looking at a period of time until 2005. Covering 24 states and 24 Mexican states and 38. These caveats are familiar with you guys as well. More circular than permanent, more undocumented than legal, And for us, this is good because it would be advantageous to focus on individuals who are very mobile. But nonetheless, so we were trying to plot these routes. So I'm sure people didn't jump across the sea, but these are just straight lines from where they are. So what we will see is essentially where they're from, where they crossed the border, and then where they went after that. So for each individual migrant, you can calculate the road distance of how they went from here, their home, to the border, and from the border to the business. What is interesting as we were looking at this particular data is the following. So we calculated something just to see whether people are strategic in their choice of where to cross the border, right? What we call depth distance, right? So it's the difference between two numbers. The actual distance traveled, right? Actual distance traveled by a migrant, minus over and above the minimum possible distance that they need to travel to go to the business. Okay? So that's that. That's that. And what you find is that people travel long distance to go to where they want to go. They will go from here to there. So that to me is very, very, very important because it tells us that this decision is made consciously. Other information that might be helpful to note are the following. So this table looks big, but there are basically three chunks. The first chunk is from 1980 to 1992. There are three columns here. The second chunk is from 1993 to 2005. There are three columns here, and then averages. And so within time interval, I have those who choose to cross via Tucson, those who did not, right? Those who choose Tucson, those who did not, and so you can compare between them and see if they're very different in these regards. So in terms of year of education, they're pretty similar. Over time, people are obtaining more education. Age at first crossing around 27 years old throughout. Percentage female very small, so in fact we have to drop them because there are many of them that are single sex. Percent with U.S. connection, many, but that fraction drops over time because many people just went and didn't come back. My guess is. And then on average, one U.S. connection. So that's that. So I don't know what's the time. How much time?
Here, 12:35, and you'd be done like just before 1, but you want to leave some time for Q&A. So turn on 15 minutes. Maybe
I should be. All right. So just some description of the data that we variables that we construct. And so the first one, of course, is to construct these network variables. And so for each individual I at time S, right, I will code a person as having a family connection if either the father or the mother or both are prior U.S. citizens. As you all know, in the MNP, you can do a lot more. You can also add siblings as well. And so we try to do some of that in the paper as well. But in this presentation, I will talk about this one. So starting from T equals start to end, I have 5 time interval dummies. Okay, and so these time interval dummy is right is equal to 1 if you migrated during a year between 1995 to 1980 to 1984, 1985 to 1989, and so on. So on 5 of these guys. And so then what are we going to do? We're going to interact with them. So you have a network connection migrating during that week. So that is my variable. So there are 9 minus 1, 8 times 5 of these coefficients estimate for each end. Okay, so that makes sense. Right? And so I have other information as well. Border enforcement, we use cumulative mileage of sector level border fencing. So there are I think New York Times reporter who filed a FOIA request to actually find out how many miles of fencing has been done every year, and so you shouldn't be surprised. Actually, fencing has been going on every year since the early 90s until now. But in addition to that, we also have border sector time interval fixed effective control for sector level changes in border policies that might be found. So is that big thing, right? Including climate that we were going to look for earlier. And then finally, we have migration cost controls. We estimated these distances, of course, that we talked about. But then we also found out as we were working that there are other things that might be interesting to estimate. And here I just briefly talk about them. I'll come back to them in that time. These are network effects on smuggler pricing via what we call, in economics anyway, second and third price discrimination, and second and third degree pricing. Where a smuggler price, right, how much they charge to take somebody across the border, depending on community characteristics. So we'll talk about that. All right, so this is how regression tables look like. It's ugly, so ignore. But what I want you to see is that there are, right, 8 of these columns of coefficient that we look for. And we also have the Chau that we estimate that is distance specific. But what we're going to look at is just a Tucson column from now on, just to show you the main action. So I'm going to skip that. And so here it is. So I show you 3 columns. So all of these are time interval interacted with network element. So do you do or do not? Red is negative, blue is positive. The 3 columns include people who are, according to the literature, increasingly susceptible to network. The full sample, people with middle school education, people with primary school education. So those who are less skilled, who are more likely to rely on networks as a source of information. And so what we find, I think, is 2, very notable things, right? These coefficient flips consistently from negative to positive. We didn't expect that going in. Second, these coefficients are bigger and more significant as we go from full sample to less than primary school. So these to us are indicators that, right, things that we think are working as push and pull forces of migration when it comes to network is also making an influence here as well. And so for those of you who don't want to look at coefficient, who want to look for marginal effects, what I calculate for you is a big matrix with less than middle school education. So the middle column here, US family time increased the relative odds of a Tucson crossing relative to San Diego by 13%. So for each time period, you can have one of these. All right, so the rest are just checked. So I'm going to go through them, and then I have a few things that I want to stop and just say. And so there are various ways of thinking about skills. And so this is, again, another piece of information that is available in the MMP with respect to occupation of these individuals that they self-declare. And so here it's just a subset of data of people who are declaring themselves as agricultural workers or manufacturing workers. So the same looking pattern. And then finally, to distinguish between proximate ties and distance ties, just a couple of days ago, there was a big New York Times article saying that distance ties are more important for people to find jobs. So those of you might have seen that newspaper article, but here for us, proximate ties is what matters when it comes to risky decision making. Consistent with right? So here I have distance ties measured in terms of not just at an individual level, but at the community level. Right? So I measure the share in your community of first-time migrant with ties to the US. And so the same flipping pattern that you see, nothing that is different. And so just because the community has network connection doesn't mean, right, that you will follow it. All right, so there are a number of things to worry about here. So depending on how much time is available, please stop me if you want me to stop at any point. So I'll talk through some of these things that you want to step back and think. So there are many ways in which network works. And so if there's anything that I've learned is that all of these are at work, right, in the same story. And so the first one is that network begets network. That is that a local history within a community of migration through a particular route might affect the cost of smuggling, right? Naturally, because think of yourself as a smuggler. If you knew that going to a place I would find a steady source of finance, right? I would be able to discount, right? Because I know I'm going to something. So therefore, to account for that network externality effect, as the calls it, we construct a community level lagged share of first-time migrant crossing choices via a particular thing. There are many people crossing via Tucson in your community, or crossing via San Diego in your community, and so on. So I construct these lagged share for each sector and estimate the following equation. Right? In the MMP, we have the smuggling cost for each crossing, and so take logs. Run a regression with log periodic cost on the left-hand side, and the community level network lag share of first-time migrants on the right-hand side. Do you get a discount if many people cross the same sector in your community? The answer is yes. It's minus the elasticity of country. Right, so in our work, and therefore, since these types of network work, right, it changes the cost of smuggling. So we decided to include the level lag share for crossers in our regression as well, to make sure that our flipping is not one. Second, a second reason why network is to get networks is because having family ties can change who is migrating. Right, if I have parents and families abroad, maybe younger people will migrate. Right? And so, and again, another way in which smugglers can price discriminate. Right? This time not because of scale, but this time because of who you are, right? Who is migrating. And so we now construct just one thought, and so we would welcome other possibilities. Construct community level average age of first-time migrants, right? So if you're older, right, do you get a discount? Right? So that's basically it. So we have third degree price discrimination text here. So controlling for year, community sector. We estimated the elasticity of law community costs with respect to the average age of first-time migrants as minus. Very small, negative. So again, we include that kind of network effect as well in our analysis. So that's the second way in which network functions. The third way in which network functions, which the last time we presented this paper, someone said, hey, what about a much simpler reason why network, right, and drive people to cross through a particular border sector? It's just information, right? People crossing, they know that works. So I just tell you. So it's not this convoluted push and pull story that you were trying to let us do. And so here, thanks to that feedback, then we have a plot. What is this plot? So again, the hypothesis of network may be providing information to people and others without the network connections might not know that Tucson is the way to go. Right, so that's the story. And so what we plot here is the choice between two groups in the data, right? People with no network connections, people with network connections, and the frequency of crossing via Tucson. This choice is the fraction of people who choose to cross via Tucson from 1980 to 2000. You see is rising, that makes sense, but the two lines are not that. So that piece of information that Tucson is the way to go is common knowledge. So people do that. Doesn't require having a family. So maybe it's not just that. All right. So there are other threats to identification too. You know, this economists. So yeah.
Sorry, I don't want to.
Yeah. So I'm done.
Oh, okay.
I can stop here too.